I'll demonstrate common configurations in winIDEA 9.21. The first use case is a hybrid AMP-SMP configuration on the Infineon Traveo-II 8M. The software architecture implements two applications, one executing on the M0 core and another executing on the dual M7s, configured as SMP. It features a hybrid of the AMP and SMP architectures, where some homogeneous cores are clustered together and run an SMP OS, like AutoSAR in this case. The heterogeneous AMP cores run their own RTOS or custom scheduler. In winIDEA's new session configuration, we need to create two application spaces, one for the app core 0 and one for the app core 1 and 2. Then we need to create two memory spaces, one for the AMP using M0 plus core and one for the SMP configuration using the dual M7 cores. The boot core is always connected to the first instance of winIDEA. In this case, the M0 plus is the boot core. The application space and memory space configuration is always done in the main instance of winIDEA. I'll go ahead and start by creating a new workspace. This will be for our Traveo-II example. So one of the nice new features is this automatic blue box selection guide. It detects the blue boxes that you have connected via USB or Ethernet. So I'll go ahead and select my IC 5700 that I have connected. And here we have the basic session configuration dialog. This is a new dialog that allows you to set up the bare minimum to get up and running and debugging a single application. So let's set up the device that we're going to be connected to, the Traveo-II 8M device. Now we want to select the symbol file. This is the ELF file. Typically the ELF file. There are other formats that we support, but ELF is the current standard. So we want to select the ELF file for the boot core. So in this case, this is the M0 core. If you have a different file that you program for code, different than the ELF file, so the ELF file has both symbols and code, and you can load both from just the ELF file, or you can, if you want to load a hex file or a binary file that you actually program to the target, you can also select that file here. So this would be the minimum configuration to get up and running. I could either program or just load the symbols. If this code was already programmed to the target, I could just do a load symbols only and start debugging just with this configuration here. But since we're running a hybrid AMP SMP configuration, we still need to set up another application space, and we also need to set up the SMP configuration before we can set up the two memory spaces that we need to set up, one for the M0 core and one for the SMP configuration. So if I click Take Me There Now, this button here, we can go and set up the rest of the configuration. winIDEA has created a default application space for me. I can use this to configure the boot core, in this case the M0 core. So I can just click Edit here. I'll go ahead and change this to app core 0. We'll make sure that the symbol file is already brought in here that we used in the initial setup. You might need to set up directories to the source files depending on where your source files are located. If the paths in the ELF files are correct or not, the source files will automatically be brought up in winIDEA if you're going to be stepping through code. If they're different or the paths in the ELF files are not valid on your local PC, then you'll need to set up the paths here. We can also set up the OS. So for this M0 core, it's just running some custom scheduler. I'm not going to be doing any task or ISR analysis on that core. So So this is enough for the application space for the boot core or the M0 core. So now we'll set up another application space for the cores 1 and 2. This is for the dual M7 cores that we're running in the SMP configuration. So now we need to add the ELF files for those cores if there's one file or two files. In this case we have two files. So here's the first file for the first core. And then we have the second file for the... Okay, so this looks good. Again, you can set up the directories if you need to point to source. If you need to set up an OS, you can do that as well. This is good. This is what we need to set up for the AMP and SMP configuration. Mapping just the M0 core to the first application space and both M7 cores to the second application space. Okay, so now let's go ahead and set up the different memory spaces in the SMP configuration that we need to configure the rest of the system. So first we'll set up the SMP configuration, and we need to bind together both M7 cores. Let's call this memory space app core 1 and 2. Alright, so we've created our SMP configuration. Now when we go to the memory spaces, winIDEA has created these default memory spaces for us. So the core M0, let's go ahead and edit that, and we'll change the name to memory space app core 0. Yes, and we want to connect that to the M0 core. That's correct. And we are mapping this to the application app core 0. So that looks good. These other two that winIDEA created by default, we'll actually want to remove those. And we'll create a new memory space. So we'll call it MS App Core 1 and 2. We'll connect it to SMP configuration, and then we'll map it to the application space that we created for this cores 1 and 2. Okay, perfect. So this is exactly what we want. We have our two memory spaces, we have our two application spaces, and we've mapped the two together. So we have our mapping of the core 0 memory space to the application core 0, and the cores 1 and 2 memory space to the application core 1 and 2. So next we need to add the remainder of the ELF files, or files that we want to program. They don't necessarily have to be ELF files, but in this case they are. We'll add those to the system. So first we'll do the M7 0 core, and now we'll add the M7 1 core. Okay, and we can arrange them in any order we want. So winIDEA will program these in the order that they're listed here. Okay, so that looks very good. So the last thing we need to do here is just select the probe. So we're just using a passive probe. Now we can click OK. And that's the configuration. Now we'll just perform a download. Okay, so we're here at the reset vector. We can just set it to run. So now we can just let it run for a while. Maybe add a variable to the watch window so we can see everything's running okay. We can stop the system. Thank you all for your time.